Hello, everyone. I'm Dr. Matthew Laske, and I'm so excited to be sharing with you behavioral safety as it applies to industrial settings. So let's jump right in. I'm first going to cover, why do we care about safety in industrial settings? I'll then discuss the principles sort of behind the behavioral safety approach to an industrial environment. I'll then talk more specifically about the process of using behavioral science in a workplace setting related to safety. I'll then share a brief example, and then we'll close just with a summary of what was discussed. So let's get into why we care about safety in the workplace. So on October 4th, 1960, there was an explosion at the Kingsport plant that resulted in the loss of 13 lives and injuring many more. And 57 years later, on the same exact day, as a matter of fact, that same plant experienced another explosion. And fortunately, in this instance, resulted in no injuries, no fatalities either. So even though we might think, the 60s, workplace safety, that's when it was really important. We've dealt with that. Not necessarily. Workplace safety is still a current issue that society faces, and our work in behavior analysis can apply directly to these industrial settings. So just to give you some statistics, I pulled it before COVID because that kind of threw all these numbers out of whack with non-workplace illnesses, COVID. So I pulled the data coming right before that. But was around 2.8 million non-workplace injuries and illnesses. And if we look at fatalities for that same year, there was over 5,000 people that lost their life working on a job in the United States. And if you look at sort of the trends here, I'm showing you injury rates as well as the number of fatalities. And since the 90s, we've done a really good job just in the United States of reducing those minor injuries, those bumps, bruises, so on and so forth. But the number of fatalities in when I look at this trend has become a little stagnant, right? There's still this need for addressing those more major catastrophic events that are occurring. So let's get into how we apply behavioral science and the process of behavioral safety and the principles behind that. So when we think of behavior, we're often trying to do the best we can under the situation and the circumstances we're faced with. So here's an example. This was at the Charlotte airport, and I was trying to wash my hands. And if you look at this first picture, that the back of the sink is too close. So if I'm trying to rub my hands like this, my fingers are hitting the back of that barrier. Not really ideal there. So what do? I'm trying to find a different way to wash my hands here. So I start turning my wrists like this. You can see in the second picture, but that's putting a pretty significant strain on my wrist there. So what's my other option of what I can do here? Well, in this case, I could not wash my hands, right? So I did. I found a way, did a little cupping here. But this goes to show that behavior in the workplace, when we're thinking of safety, oftentimes behavior is going to go where there's reinforcers or where there's the path of least resistance to get the job done. Let's contrast this is another sink that I found. This was somewhere between Illinois and Kansas, was on a road trip. And look at this, plenty of room to wash my hands. There's even a soap and an air dryer, so my hands never actually have to leave the sink. No dripping water on the floor. So this is the principles we're kind of taking. If you change the environment, you can change the behavior. In this case, I didn't need to, no one needed to layer on feedback and give me feedback on washing my hands a certain way, right? In this case, you changed the engineering and you changed my behavior in this instance. So in safety, a lot of initiatives are focusing on changing the environment, such as the equipment, because you changed the behavior as a result of that. You don't need to introduce feedback or other performance management techniques that you might want to use. So within behavioral safety process, you're collecting tons of data points around these different events, whether it's the physical hazards in the workplace, maybe some at-risk behavior, recordable incidents, and every now and then you have to collect one of these data points. And the goal of behavioral safety is you want to try and narrow the focus. So figure out what are the critical behaviors, what are the environmental hazards, the equipment that the employees are facing that might lead up to these more catastrophic events. Then once you know that, that's where we come in with our behavior analysis, understand the environmental contingencies, so we can hopefully remove the potential for that serious event from occurring. I want to take a second to contrast this with kind of a traditional view of how maybe others view employee behavior. So I would say that maybe leaders understand behavior, or that they think they do in some cases, where they might say something like, well, behavior is what gets people hurt. So if you look at this figure here, you see the injury, and the last thing that occurred was someone's behavior. Someone's behavior was interacting with a hazard, and that resulted in the injury. So the leader points the finger and says, aha, see, it was your behavior that led to this injury. But if you think of piping, or if you ever have like a plumbing event going on, you're trying to figure out what's going on with the plumbing, it's usually not at the point of release. There's things going on behind the scenes. So when we're understanding behavior, we're understanding it from a systems perspective and understanding, where maybe there are leaks being created in the system that's resulting in the behavior that might lead to an injury. So you can see some examples here. And if you tidy up those other areas of the system, you're able to maintain that steady flow of behavior, not resulting in an incident or an injury. So this is kind of the principles behind behavioral safety and behavioral science applied to workplace safety. We're going to think of it from a systems perspective and addressing those barriers. So let's talk about the behavioral safety process itself. I wanted to take a moment to highlight really the women leaders in behavioral safety. Some of the founding behavioral scientists that were applying the principles of behavior to workplace safety were women. So I thought that was really important to highlight. And I'm going to move out of the way here so I'm not blocking anyone. But from bottom left, and I'll kind of work my way up, we have Alicia Alvaro, Angie Levin, Judith Kamaki, Beth Zolzer-Azaroff, Judy Agnew, and Nicole Gravina. And then in our bottom right, we have Angelica Grindle. So there's a UR code here. It's going to take you to an article that really highlights these pioneers and continued leaders in behavioral safety. So if you scan that, it'll take you to a blog post discussing that. But I just want to take a moment and highlight that here. So in articles and books, you're going to read about the behavioral safety process, and there's slight variations depending on what source you go to, but I just wanted to make these resources available to you if you want to learn more. There's the work of Scott Geller. I have several of his books here. Judy Agnew wrote a really good book on sort of a supervisor perspective in safety. Dom Cooper, Tom Cross, and then on the far right, we have Terry McSween's book, and then Dr. Tim Ludwig and I wrote our book highlighting some of the best practices of behavioral safety, which is what we're going to highlight next in terms of the process. So pretty straightforward. If you go to different books, you're going to see similar steps and process, so that's what we'll be talking about next. And in the book, we have a model that we present. Again, it's going to be fairly similar to what you might get in other sources as well. This QR code will take you to the book where you can learn more. So I'm going to blow this up here. First step is doing your sort of risk analysis and pinpointing, which then leads to direct observation and performance feedback. You then need to ensure the engagement in the process is reinforced. Then you do your trending and functional analysis, or your functional assessment, figure out why you're seeing variance in behavior. You then implement some intervention, and that doesn't have to be just targeting behavior. It can be targeting the hazards in the equipment and environment. And then you evaluate whether or not that intervention was successful. So let's kind of dive into each of these steps in a little more detail. So with risk analysis and pinpointing, here you need to come up with, what are you going to focus on? What are the critical tasks? What are the critical behaviors that need to occur to prevent harm in the workplace? So you can do this by looking at injury analyses, safety assessments that are being done, incident data, near miss data, and also just going out and doing observation, talking to people, asking what jobs they're doing, where they see the big hazards, and that's sort of your foundation, your risk analysis. From that, you need to pinpoint and identify what behaviors are crucial to maintaining a safe work environment. On the screen here is an example of two different behavioral checklists across organizations, and you'll see variability in how these behaviors are pinpointed and defined. So on the left, you're seeing behaviors like line of fire, eyes on task, kind of these broad descriptions of multiple behaviors, or thinking of it like a response class where there's multiple behaviors that could occur in that same class. On the right, you're seeing a little bit more specific definitions of behavior. Set up air horn prior to opening sample valve. So in this case, more of an industrial manufacturing setting. So you can either go one of two ways. A broad description like on the left that allows an observer to observe a whole range of behaviors, or you can get a little more task specific like that seen on the right. But ideally, whichever direction you go with this, it's informed by data of where previous incidents have happened or where you might predict that the next incident could occur. You then engage in a direct observation process. Tons of different ways you could do that. I won't necessarily dive into the specifics here, but ideally you're listing the behaviors or what tasks are being observed, so on and so forth on a checklist. Here's an example here. And then usually there'll be some form of performance feedback. That could be the conversation between the observer and the observee, or it could be graphic feedback provided later. Here is an example of a observation checklist. And on the back, there's the thanks conversation, which is just a way to facilitate a discussion in the field. This comes from Dr. Tim Ludwig. You scan that QR code, it'll take you to the book where the thanks conversation is also discussed. You'll also see on the right a coaching card. So it's not just, it might go beyond just someone doing an observation, but how do you know those observations are of quality? So this is where coaching the observer can come into play as well. And that's another form of performance feedback. Once you have kind of this bare bones system going, you then need to make sure there's engagement in that process, whatever that might look like. So this includes targeting, behaviors of supervisors, managers, executives, and leaders of what behaviors are important for them to engage in to support the process. So will the roles differ? Is it a traditional hierarchy? Is everyone working at the same level? Are the behaviors going to differ across groups? This is where you're figuring that out and then making sure there's reinforcement for those behaviors. You then do your trending and functional analysis or functional assessment. And I'm going to move out of the way here so you can see all the different tools available. But here you're trying to identify variance in safe or at-risk behavior, and then determine the function or the cause for that behavior that might be occurring. I have a few of the tools. You can do some data analysis and ADC analysis. You could use the performance diagnostic checklist. This link here will take you to Dr. Wilder's presentation, where he provides an overview of the performance diagnostic checklist. You could also do a systems analysis or systems assessment. The QR code there will take you to Dr. Tim Ludwig's tutorial as well, talking about systems in the workplace. So just some more resources available for you there. Here's an example of trending data. This comes from Marathon's AWARE behavioral safety program, and they were using the broader pinpoint of body mechanics. And you can see we're looking at the percentage safe across consecutive months, and pretty high percentage safe. But then after around month 24, a couple of years, you're starting to see this increase in variability. So this is your data analysis. You're trending, you're looking at the data and identifying, hey, there might be something going on here. After you've done that, that's where you're then, using some form of an ABC analysis to identify the cause or the function, or some other form of assessment you might use. And then you're implementing some intervention. And it doesn't have to be just targeting behavior. You can eliminate hazards, change tasks, equipment, so on and so forth. This QR code is going to take you to the Cambridge Center for Behavioral Studies, where you can read about these accredited companies for best-in-class practices in behavioral safety and read their full reports that will have these data as well. But what you can see here is this is the same program, And after they identified that kind of broad risk in body mechanics, they got more specific. They figured out what was the certain types of equipment where this risk was occurring, and they were seeing there was some overextending of the body that were occurring specific to that equipment. So as you can see here, they implemented around the second year some manager antecedents. So the manager would go and say, hey, we don't want to overextend when we're doing this task. You can get hurt. And you see an increase in the behavior, but it didn't maintain. You start seeing that decrease in trend again over time. So then they did their functional assessment, did an ABC analysis, and that resulted in the equipment being changed. So here, it wasn't a target of the behavior, it was targeting the equipment they were working with to eliminate the possibility of the overextending behavior. And then the last step is the evaluation. So making sure the intervention was implemented with integrity. And then also, did that intervention successfully change behavior, or in other cases, eliminate the hazard, so on and so forth. So here's another example from an accredited behavioral safety team. This was a contractor. And what you're looking at here is I flipped it. So instead of percentage safe, we're looking at the percentage of at risk, sort of were they finding risk in the workplace. In our black circle, you can see some variability in working in hazardous weather conditions. And in this program, there initially wasn't a lot of trust. So that's why you're seeing that at risk is pretty low in the beginning with some variability. And what happened is once the risk was found, it was then up to leadership to then make a policy change around working in hazardous weather conditions. So before it was kind of willy-nilly where people, were allowed to work in these environments, so risk was potentially occurring. So the leadership team made it so, we just can't have this happening at all. We're not going to put you in that situation anymore where you could be at risk. What's really interesting, though, and what I wanted to share for this story is what you see in the next month. So immediately after that, no more risk was occurring. They eliminated that hazard. But you start seeing an increase in risk for respirator use. And what happened here is that the employees started seeing that this program was successful. It actually resulted in change that benefited them. So then the very next month, they started observing and finding risk around respirator use. Now, the respirators were an issue heading before that, but there wasn't really observations or reporting of the risk around it until change was actually occurring. So in this case, risk was found. They identified the risk, which then resulted in their management team purchasing more comfortable respirators, and then that risk immediately decreased and maintained for several years. So this is that evaluation piece. Does the change actually result in a change of behavior? So really briefly closing up here, I just want to talk about who's involved in the behavioral safety process. And really, you need a manager and employee partnership. So your frontline employees are really going to understand the risk that's occurring, where the next event's likely to occur, where the hazards are. It then becomes up to the management team to eliminate and remove those hazards in the workplace. So if you have one without the other, you're going to be less likely to succeed in keeping the workplace safe. A point I also want to discuss is some misconceptions, and big one that you might hear a lot if you're a behavioral scientist getting into this area is that by focusing on employee behavior, that it blames the worker. However, there's really no blame. This is why we're talking about as a misconception. Think of the principles I discussed, where we're really interested in those systemic and environmental variables that are causing variation in the workplace. So it's not about the worker, it's about the environment they're put in. So that's one of the misconceptions. Another one that you might hear is that it focuses resources away from hazards because there's the perception it focuses exclusively on employee behavior. Again, that's not the case. In some of the interventions I just talked about, they weren't necessarily intervening on behavior. They were intervening on the environment to remove the hazard, change the tools, change the equipment in that case. The third one you might hear is that it results in underreporting because it includes incentives for not having accidents. So this is absolutely false. Good programs do not include incentives for ongoing periods of not having an incident. And OSHA recommends not having incentives for periods of time without an injury also. So again, another misconception there. So with that, I want to close with a brief story of kind of the example of seeing this in action. Shared a few examples before, but just kind of walk through the various steps. So I want to take you to a behavioral safety team at a raw materials manufacturer. And this isn't the actual equipment. I'm just using it for illustrative purposes. And they had a task where they would collect excessive material in these big containers. And over time, once the container got filled, they needed to dispose of that material appropriately. However, what would happen is sometimes these large containers, they would get clogged up. So when they were trying to empty out the material, they'd be clogged. So then you'd have all this material backed up. So this task then became hazardous because they had to break free this sort of clogging that was going on in that container. So the operators, they would then have to manually unclog that valve. And what they would do is they would take a rod, slide it in, break through the container. They'd have someone that would open it on the side. But unfortunately, if you're breaking free that material, you got to keep the valve open. And in that case, when the material breaks free, because you have the valve open, it's coming out on the operator in that case and can come out with a lot of force. There's your hazard there, right? Quite dangerous, talking about raw materials here. And what was interesting is, as dangerous as this task was, the operators affectionately referred to this as rotting the dumpster. But if you talk to them sort of behind the scenes, there was actually a lot of hesitation in doing this test. This was something you didn't want to do because of the severity of the hazard, depending on what material was in there at the time, how long it had been sitting, so on and so forth. Now, this had been an issue for years, right? Hadn't really been addressed, but their team decided to start conducting observations around this specific task. So these data are going to show the percentage of risk identified on our left axis. And on the right, we're going to look at the number of times that the dumpster was observed rotting. And that's going to be your gray bars that you're looking at here. We're going to be viewing this over consecutive months. And what you're seeing in this first couple months is some variability in risk being observed that they were finding having to rod this dumpster. And their two pinpoints were related to whether or not there was an engineered tool that was used specifically. And then our open data path is an aggregate of other rotting behaviors. So risk was occurring, okay? And their first intervention is they increase the availability of those engineered tools. They would get misplaced. There wasn't enough of them. So that's where you start seeing people use sort of alternative rods, just whatever you could find, a steel rod. So they manufactured more tools, and you start to see that decrease in engineered tools avoiding being used or not being used. However, they're still routing the dumpster a bunch here, being exposed to that hazard. So they made some modifications of the equipment. This was a changing in the positioning of the valve, which would allow an operator to rod it from a safer distance. They also, and I know less about chemical engineering here, but they changed something with the compound that would try and decrease the likelihood that it would get backed up. So you can see a decrease in some of those other rotting behaviors where their body needed to be positioned, but also a slight decrease in the gray bars, or the number of times they actually had to be exposed to this hazard. But this isn't good enough, right? They're still being exposed to that hazard. So again, modified tools, modified equipment, trying to make it less likely someone could get exposed to this hazard. And it wasn't until after a year of kind of going through and talking about this that they ended up on a more systemic and process changed here. So what happened is they found that when the dumpster was full, it would get sent to a different part of the plant where it'd be disposed of appropriately. However, sometimes it would be left sitting there, which longer it's sitting there, more time the material has to get backed up. That was contributing greatly to the clogging. So what they did is they actually redesigned their process so that when the dumpster was approaching capacity, they were able to sort of radio in ahead of time let them know that the container was going to be on their way so it could get disposed of more quickly. So this was a process redesign where this intervention not only mitigated the potential at-risk behaviors, but also greatly decreased the likelihood the dumpster even needed to be rotted in the first place. And you can see they had some months where it was only needed to be done once, sometimes even fewer. This 20-year issue that they had been dealing with was resolved through this process. And if you think about the time, how long it took to kind of get to this solution, if they'd have started with thinking about the work process and more of a systems approach, they might have came to this solution earlier rather than trying these modifying tools, modifying the equipment, doing specific observations around this task. Started to ask about figuring out why is it getting clogged in the first place. So again, just an example to show this approach in action. So closing out with the example, I just want to give a brief summary of what was discussed in this tutorial. So as behavioral scientists, we have a powerful tool at our disposal. And that tool is the knowledge that behaviors are influenced by the environment and that we have the ability to change those contingencies that might influence behavior. So when we think of the events in the past that were occurring that have resulted in lives being lost and that continue to be lost in the workplace, we have a powerful tool here that we can be using. So I encourage you to learn more about behavioral safety applied to industrial settings and how you can help contribute to this meaningful cause and hopefully prevent serious injuries and events like this from occurring in the future. So thank you for your time. This QR code will take you to the OBM tutorials instructional page where you'll be able to see more videos of behavioral science applied in organizational settings in different ways. Thanks again.